Find the inverse by using elementary row transformations. Now here there are various ways to find out the inverse. For example, if we call A, then the A inverse is simply when you multiply these two, you'll get the identity matrix. And when you multiply A with any value, it gives you I, then that value, that X, is nothing but the inverse. For example, if you multiply both sides by A inverse A will be identity matrix, and on the right hand side you get A inverse into I. Again it will be A inverse only, and multiply anything with I, it will be X. So the inverse, this is the way we compute the inverse. But there are other methods also. For example, we have the elementary row transformation. So in this elementary row transformation, what we do is, we have a matrix and we purposefully multiply this with identity matrix, and we know that multiplying any matrix with the identity matrix is going to give that same matrix back, right? So A will be equal to identity matrix into the A matrix or any matrix. When you convert this A matrix in any way to identity matrix, that means the conversion meanwhile for this I, on the right hand side this I, will be A inverse, because you can only get an inverse when you multiply the number with the value with its inverse value. For example, A multiplied by A inverse will only give you I. So the whole idea is that we write A equals IA, then we make this left A as I, because A into A inverse is identity matrix. On right hand side, the I has to become the inverse by the theory and by the discussion of all the adjoint matrix. All this we have done up till now. So we'll start with this. A equals IA we have to do. This is what the thing you have to do in 2 by 2, 3 by 3, all the matrix. So I'm writing this A matrix. It's 7, 1, 4, minus 3. I'm writing the identity matrix here. So 1, 0, 0, 1. This matrix will be the inverse matrix after we complete all the row transformation. And on the right hand side we write A, that is the multiplication with A. So whatever changes we do on the left hand side, the same transformation, same row transformation will be carried out on the right hand side, left and right, both ways. So our intention is to make this left hand side matrix, A matrix, as the identity matrix. There are 2 rows and 2 columns. So we can either perform the elementary row transformation, we can perform elementary column transformation, but we will try to do only the elementary row transformation. So here we need this identity matrix. 7 will be 1, minus 3 will be 1. So first we will do row 1 will change and multiply it by 1 by 7, because we need 7 as 1. We are trying to make this matrix as identity matrix. So what you do, the whole row, left hand side, right hand side, the first row has to be multiplied by 1 by 7. So 7 by 7 is 1. This is 1 by 7. This will remain like this for negative 3. And on the right hand side, again the first row has to be multiplied by 1 by 7. So 1 by 7, 0 into something is 0, 0, 1. Now one of the value we have got. Now we'll make this 4 as 0. So row 2 will change, row 2 minus 4 into row 1. Because if you multiply this row 1 with 4, you'll get a 4. And you subtract it with row 2, so 4 minus 4 is going to be 0. So essentially the column, the diagonal will have to be 1, others will be 0. So we are making 1 more as 0. So 4 minus 4 into 1 is 0. Minus 3 minus 4 into 1 by 7. So that is going to give you what value? Because that will be minus 25 by 7. How this is coming? I'll just show you, because actually we are going to add it, because we are subtracting minus 3 minus 4 by 7. So we'll take a negative outside, and it will be simply 3 plus 4 by 7. 7 3 is a 21, 7 3 is a this this 7 is 21, 21 plus 4 is 25, 25 by 7. And since we have taken negative outside, this I am doing it right now. So this is 3 by 1, 7, 3s are 21, 21 plus 4 by 7, that is 25 by 7, right? Negative 25 by 7. So we have 1 and 0. We still need, and this has to be done on the right hand side also. 0 minus 4 by 7. So minus 4 by 7. 1 minus 4 into 0. It will not change. It will remain as 1 only. Okay. That A is, continuing. I am not writing. It is continuing. So 1 and 0 has come. Let us make one more 1. This minus 25 by 7 has to be made as 1. But remember, whenever you are doing any kind of transformation, the 1 and 0 which you already made should not change. So we will multiply the row 2, because it is minus 25 by 7. If you multiply it by minus 7 by 25, minus minus will be plus, 25 gets cancelled, 7 gets cancelled, you get 1. So whole of the second row, that is row 2 we are multiplying. It's not row 3, it's row 2. There is a slight correction. Row 2 will multiply by minus 7 by 25. So you multiply 0 by minus 7 by 25. First row will remain like that. 1 by 7. This is going to be 0. Minus 25 by 7 multiplied by minus 7 by 25 is going to be 1. Just because we wanted this to be 1, that is why we did all these things. So first row will remain like that. 1 by 7, 0. And now we multiply minus 4 by 7 by minus 7 by 25. So minus 4 by 7 into minus 7 by 25. Minus minus becomes plus. 7 gets cancelled. It's going to be 4 by 25. And then this 1 multiplied by minus 7 by 25, it is going to be negative 7 by 25. Okay, one more thing is remaining. 1 by 7 has to be made as 0. So what we'll do is, we'll multiply this row 2 by 1 by 7 and we'll subtract it from R1, row 1. So you might be questioning why we are not multiplying this whole row by 7, because 1 by 7 will be 1. But we don't need a 1, we need a 0. And 0 can only be obtained when you use this 1 below 1 by 7. So 1 by 7, if you subtract by 1 by 7, you get 0. You have to multiply this 1 by 1 by 7 and then subtract it with 1 by 7. So whole thing is, row 1 we are changing to row 1 minus 1 by 7 into row 2. Okay. So what do you get finally? This finally I am doing. Row 1. So this we are executing. So we get 1. This see. Row 1 minus 0 into minus 1 by 7, it won't affect. That is going to be 1. But the second thing which we actually wanted to become 0, 1 by 7 minus 1 into 1 by 7, and that is going to be 0. 1 by 7 minus 1 into 1 by 7, that is going to be 0. Now this also gets changed. 1 by 7, 4 by 25 minus. So row 1 minus 1 by 7 minus 4 by 25 into 1 by 7. And let me write the final one. This computation I hope you will be able to do. So this final will be, this is going to be 4 by 25. 1 by 7 will become 3 by 25. And this again R1 minus 1 by 7 into R2. This is going to be 1 by 25. So 3 by 25, 1 by 25 the first row, 4 by 25 minus 7 by 25 second row. This is going to be your A inverse. Because whatever you are doing on the left hand side, you have to perform it on the right hand side as well. Right? So this is the final identity value. And this is A. So what should be here? It should be A inverse. So this is final A inverse. This is going to be your A inverse. I hope you got the idea. So final value I am writing again. 3 by 25, 1 by 25, 4 by 25 and minus 7 by 25. This is your A inverse.